Alright, so while you guys are sitting around taking a break, let me talk to you guys about the one thing I want to talk to you guys about, which is, who here is in their 20s? Okay, so you guys, alright, so who here knows what a Roth IRA is? IRA, a regular IRA is? 401k. Okay, so we'll talk a little bit about Roth IRAs first. Or IRAs, or IRAs in general. The idea being that when I was in my 20s, one of my friends told me, who's a financial advisor, who said, if you save $1,000 a year, every year in your 20s, you'll have more money when you're 60 than if you saved $1,000 a year every year in your 30s, 40s, and 50s combined, because of the way money grows. So, yeah, it compounds. So, now, here's the problem. When you're in your 20s and you've got this credit card bill you're trying to pay down it's 15%, you need to pay that down, right? Mm-hmm. But even if you can stick aside $20 a month, $20 a month, that's like one dinner a month, right, with your friends. Then it's not much, but it helps. It grows. So if you start off with just doing $20 a month, that's $240 a year, and add that every year, then after 50 years, so if you do it when you're 20, then when you're 70, that $240 a year becomes over $82,000. That's the way this all works. It's really important to start early when you're young, even just a little bit that you wouldn't even notice, right? So some of the best options for this, if you're like, who has like no idea how to get started on this? Are you guys all pretty good? Yeah, you guys are in pretty good shape actually. That's not bad. So I would recommend T. Rowe Price or Vanguard. They both have what we call no-load funds, so they don't charge you to put money into them, stuff like that. And I would suggest, if you're just starting out, I would pick what we call an index fund. So maybe like the 500 index, which is the S&P 500 index of them, or other index funds.
Okay.
Why would I recommend them? Because these have, so I don't know, a few years ago, like when the market went south, I like took my money that I had my parents had put money in Wells Fargo for me, and I dumped it into just like a regular savings account that made like, 2-3%, something like that. And I forgot about it because I spaced out. So then 5 years later I went back, and my $10,000 had become $10,000 plus $1.21. Yeah. Because they were charging me like 2 or 3% a year to manage my money. Right? That's what we call an expense ratio. So the nice thing about these ones is these funds here have low expense ratios. They're around, expense ratio is the word for it, they're around 0.24%. In other words, 0.0024. Right? So for $1,000, they'd only charge you $2.40. Right? Very, very low amount. And then if you're starting with something basic, I would say just go for that. Some of you guys know more about that, so you can be more, whatever. But if you're 20-something and you have no idea, that's a good basic. Let me know how a Roth IRA works. Okay, so if you're, if you make less than $100,000, you can put your money into a Roth IRA. You can contribute up to $6,000 a year, which if you're struggling to do $240 a year, that's not you. But you can do up to $6,000. The thing about it is, you pay taxes on it now, put into a Roth IRA, it grows. When you pull that money out, you pay no taxes at all on any of it, which is pretty sweet. Whereas if you put it in a regular IRA, you don't pay taxes on it now, but as it grows, when you pull money out, all the money that you pull out of it, you pay taxes on. Does that sort of make sense?
Well, the theory is if you do a Roth IRA, theory is that you're going to make, that you're only going to make more money, right? Like your career is going to get better. So
right.
So it's like if you pay the taxes now and you're like going to school and you make less money, then you pay taxes now. You don't have to pay when you're making like really good money. That's like the theory.
That's the theory, is that later on you'll have more money. And that's probably true. I mean, you probably have less money coming in now than you will be in your, like, when you're like 60 or 70. Now, there are some things like, you can't touch this money until you're 60. Once you put it in there, you better just forget about it. Right? Don't even think about touching it until you're 60. Pretend like it's not even there. That's the easiest way to do it. And then just when you're 60, you're like, okay, good, now, and don't think about it. Because you watch it, then all of a sudden, when I was in my 20s, my money was like, oh, going up a little bit. And then somewhere in my late 20s, it did this, because the stock market just like fell. And I'd be freaking out. I'd be like, oh my gosh, my money became like a lot less money. But now it's like grown away a lot. So just don't even think about it. Just forget about it, put it there, stick it in an index fund with a low expense ratio, and just don't sweat it. That'd be my suggestion. Okay, good. Who knows what a 401k is? So 401k is basically your employer matches. They give you some free money. So if they match, say they match 50% up to 6%. What does that mean? That means that you make $1,000. You contribute 1/6 of that, or 6% of that, sorry, 6%. So that would be you contribute $60. They will match half of that. They will put in $30. You just made $30. Boom, right away. So your $60 just became $90 for doing nothing. So employer matches are really important. However much, so they may match up to 6%, they may only match up to 4%, whatever they match up to, that's the percent of your paycheck you should put into that. Does that make sense? Because that's the percent they're going to give you some matching funds. They're not going to match it exactly the same, but they'll match, you put in this much, they'll put in half that, usually. Usually they match 50%. So that's free money. You should absolutely always do that first. So that should be the first thing you do, is max out the 401k that your employer matches. If they don't match, then you don't have to put anything in there. It's not a big deal. Then I would go with the Roth IRA first and put your money into Roth IRA first. But at any rate, it's important to start saving early so that you are in good financial stead when you're 50. You don't have to worry about your retirement, because you know that whatever you have when you're 50 is going to double and double again. There's this rule of 70, which says that whatever percentage it is, it should be multiplied to, so like say 6.5% on average it goes up, then it means every 11 years your money will double, roughly. So if I have $250,000 now, 11 years from now I'll have $500,000, 11 years from that I'll have $100,000, right? So that's kind of how that works. And it starts off, like doubling starts off really low. Like if you start off with 20,000, 11 years becomes 40. 11 more years becomes 80. 11 more years becomes 160. So I mean, 11 more years becomes 320. So it gets big really quick, right? Okay, enough of that. Let's talk about ANOVA. ANOVA. This is that super easy, very, very, very straightforward one that should be everybody's favorite, right? Because we cover it very lightly and it's super straightforward, especially the way we do it. So here, 11.1 and 11.2, we were talking about categories and frequencies in the categories. The words will have to say frequencies in them. This one, we're talking about means. 11.3 is means. We're comparing 3 or more means. 3 or 4 or 5 means. So our H naught is going to be that the first mean equals the second mean equals the third mean, and so on. And then we're going to throw each of those categories. So you have a category, and it has a bunch of numbers. You have another category, it has a bunch of numbers. So you have all these lists of numbers for each category. You're going to throw each of those lists into your calculator, into a list, and then you're going to do stat calc ANOVA, list 1, comma list 2, comma list 3, comma list 4, and it will give you a p-value. This is the opposite of what we've been doing. We've been looking at critical values, and a critical value, the further away you are from 0, the bigger you are, the more unusual you are. This is the opposite. We're looking at p-values, probabilities. So probability, p-value is the probability of getting a sample like yours. If your probability, what's our guideline for unusual? 5% or less. So if your probability is 5% or less than alpha, then it's unusual. Right? If the likelihood is alpha or less, 5% or less, it's unusual and you reject H naught. If your p-value is more than alpha, then it's not unusual. It's, you would not reject H naught. Okay, so let's take a look at some problems here. Kind of what I just said a second ago. So I guess we don't need to, maybe I'll put it in here. So, I guess we should talk about this. So again, we're looking at the difference remember we talked about like heights of 5-year-olds, heights of 6th graders, and heights of seniors in high school?
Yes.
And we talked about comparing their between variance to their within group variance. When the between group variance is a lot different than the within group variance, then we'd say that they're different and we would reject H naught. But like say we looked at like seniors from California and Florida and Texas, and if their between group variance is about the same as their within group variance, then we would not reject H naught. And then you would say, okay, the means are probably about the same. So that's kind of what we're looking at, that ratio of the between group variance over the within group variance, right? So we're taking the between group variance and dividing by the within group variance, and seeing if we get a really big number, then that means that this is a lot bigger than this is. That's our F value. So I will give you the between sample variance, or the between group variance, I might call it that, and the within sample variance, or I might call it the within group variance, and ask you just to compute the F statistic. All you gotta do is divide those two. In this problem, I'm not giving you the numbers and the lists and everything else, so you can't do it with your calculator the regular way. I'm just giving you a very simplified version. Here's this, here's that. What's the F statistic? Just so you know, just so you can prove to me that you realize that F statistic is the between variance divided by the within variance. Good? Does that sort of make sense?
Yes.
So it's a micro, tiny bit of a problem. It's a very small, like 3-point problem, just so you understand that one little concept. Before you do, the whole test will be with data and other stuff. That'll be a separate thing. This is just a separate little tiny one. Yeah, X.
So do you have a sample of what that wording will look like? So
I would probably be something like in comparing, I don't know, sizes of dogs or weights of dogs. Labradors had of different species of dogs. They had a between group variance of blah blah blah. They had a within group variance of blah blah blah. They had alpha is 0.05. N is blah blah blah. I don't know. I might throw out some other things there. Compute the F statistic for this.
Cool.
Yeah. But I'm not going to give you. You won't have all the numbers to do. You won't have the lists of stuff to put in your calculator. Yeah. Here's a quick summary of them, of what to do. So H naught, mu1 equals mu2 equals mu3, and so forth. H1, at least one differs. Step 2, alpha equals blank, whatever alpha is. Step 3, put the first group in list 1, second group in list 3, and so 2, and so on. Stat test ANOVA of L1, comma L2, comma L3 to get your p-value. Step 4, compare your p-value to alpha to see whether you reject it or not. Again, one of my students had a great thing. She said, small p, when p-value is small, nope.
Nope.
Yep. I don't know.
Let's not go down that way.
When p-value is low, nope. Yeah.
Still going that way.
Yeah. When p-value is high, so when your p-value is pretty big, then H naught will fly. In other words, your H naught's good. When p-value is low, H naught must go. Yeah.
That's nice.
I know, I should write that down.
Is she a poet? When I poet.
Yeah. So I'll say it one more time.
Shake.
When the, I know. Well, and she said, Pam said she didn't come up with it. She found it on a video. But when p value is
Hi.
high, h naught will fly. In other words, it's good, right?
Well, you could also say hi too again, right?
Yeah. H naught will fly. H naught it flies, right? It's good.
Hi.
When the p value is low, h naught must go.
Rejected.
Yeah. Exactly.
That's cute.
I should write that down. I should write it. Actually, I should write it on here.
In honor of that.
Yeah, I know. All right. So let's take a look at this one. You guys are done with this, yes?
Yeah.
Great. So first things first. H naught is mu1 equals mu2 equals mu3. Incidentally, you can't have more than 3 lists. We just happen to work with only 3.
Yeah.
All right. H1 is at least 1 differs. Step 2, alpha is 0.05.
Yeah.
Step 4, or 3, sorry. Stat, test, ANOVA.
L1, L2.
Yep, L1, comma L2, comma L3. And this is L1, this is L2, this is L3. And you end up with F of what?
3.9.
More.
3.949, and your p-value is
4.5.
great. Now, step 4. Are we going to reject H naught or not reject H naught?
Do not reject.
Right, we did not get anything unusual. This is not unusual. We only reject H naught when we get something unusual. And then we celebrate, we write a paper. 5. So,
There's not enough evidence.
yep, not enough evidence.
That's
No,
what I mean.
so we're gonna make it easier than that. Not enough evidence to say means differ.
Yep.
A repetition.
That's it.
Would we get points marked off if we said there's no sentence?
No, that's okay. But this is, all you gotta do is say this. It's super straightforward. I'm gonna make this as easy and simple as possible. We are covering it very lightly, just touching on it.
Thank you.
Good. Now, I need you guys to do the following. Oh, no, not yet. Let's talk a little bit about these guys first. We talked about it last class. We'll talk about it again. The Q's. I'm going to add in the word frequency here. Frequencies. Right? So, the first one, if you have 2 different variables, they don't have anything to do with each other. Well, yeah, but they're not like red and blue and green. They're totally different things like dogs and
Cats.
income, a person's income, right? An owner's income and dogs, or something like that. 2 variables that you're trying to find a relationship between. So you're looking for a correlation. There are 2 different lists with numbers in it. So like people's income and how many dogs they own, right? Something like that. Cars and revenue. And often they'll say correlation. That's chapter 10. It means that this is an X and a Y, like your Lab 10 project, right? So that's chapter 10. Oops. That's chapter 10. If you're talking about frequencies and categories, so here you have categories. You can have categories across one way and just frequencies inside of them. Not lists below them, just frequencies. One row of frequencies that goes with them. Anytime you have these categories of frequencies, you're talking about chi-squared. If you have just one row, one variable with one set of categories, that's your chi-squared list, 11.2. 11.2
Isn't that one?
chi-squared list. I'm sorry?
Isn't that 11 point? No, goodness of fit. No, isn't that goodness of fit?
Oh, I'm sorry, 11.1. I'm so sorry. 11.1. My bad. Thank you so much. This one here is 11.2 chi-squared matrix. Yeah, I screwed up. The old book is 11 point. They shifted everything by chapter. So this one is where you have categories here and categories here. Right, so now you have a whole table of frequencies because it's not just one row of frequencies, but because you have it for different categories, you have one row for each of these different categories here. So you have categories and categories, you have a whole table, a matrix. Right, so that's that chi-square matrix. And then the last one is the 11.3, that's the ANOVA, where you have multiple lists.
And me.
So categories, but you have categories, but not just one here, one here, one here, but lists below them, and nothing here. You guys see what I'm saying? Not category, just categories here, not categories there. So it's not a matrix because there's no categories here. It could go this way, so you can have categories here, but nothing here. So it's just lists because there's no categories this way.
Yep.
Right, so categories either here or here, but not both. Good? All right, that's ANOVA. So I want you guys to take a minute and try to figure out which of these, just looking at the pictures, which one of these could be which one, to yourselves, no talking. So 15 seconds on your own.
I need glasses.
Okay.
Talk to your neighbors.
This bottom one is am I mixing it up? What's the
11.2, the
That-
chi-squared
yeah, no,
of matrix.
Yes. What was the that one? No. That one?
None of
No.
them.
Wait.
All right, so guys, which one's the top one?
ANOVA.
11.3.
ANOVA? Why is it ANOVA?
List.
Yeah, because there's categories here, but there's not categories here. Do you guys see that?
Yeah.
Make sense? There's categories on both, and you might, and also they're not the same size. Okay. Great. How about the one below it?
The which one? The
This one here.
matrix, chi-square matrix.
Chi-squared matrix. Why?
It has categories on the side.
Categories on top. Oops. Categories up top, and categories on the side. Sports on top, and then gender on the side. And there's this matrix here. Do you guys see the matrix? So this is chi-squared matrix. Okay, how about the bottom one?
That's chi-square list. Goodness of fit.
Oh, wait.
Well, so you got categories across the top, but don't have categories across the side too? Isn't this a matrix?
No.
No,
No,
that's
it's not me.
Why
That's
does it have
not.
categories alongside?
Those are data. Those are the data you get.
Those aren't categories.
Observed and expected.
Those are different rows of.
Those
Well,
are
these
data.
say observed and expected.
Yeah, data.
So this is my observed list.
Uh-huh.
This is my expected list. Do you guys follow what I'm saying?
Yeah.
So it's really just one list of observed and one list of expecteds.
Yep.
That up there is just, those are just observeds. That's a matrix of just observeds. The observeds here are just these guys here. So the observeds make just a list. The expecteds are like a whole, so it's a separate list. You guys kind of see what I'm saying? This is a list, the observed list. This is L2, your expected list. So you do a chi-squared list because you have, they aren't different parts of the same thing. They're the same thing, but observed and expected. They're two versions kind of the same thing, the observed ones and the expected ones. You know what I mean?
So it's chi-squared.
Yeah, it's chi-squared, but it's a chi-squared list. You guys sort of see what I'm saying?
Yeah.
Like this isn't male and female, and then you would compute the expecteds of accidental male and accidental female. It's just accidental. There's no further categories of accidental. Does everyone understand what I'm saying?
Yes.
If this was male and female, then I'd have accidental females and accidental males. Right now, I just have accidental, period. Because this is what I've got for that. And then I have the expecteds of the accidentals. So this is my chi-squared list, 11.2. Or 1. Sorry, 1. I always mess it up. All right. This is 11. This is 10. Chapter 10. Oh,
No,
this is
11.3.
11.3.
11.2.
Wow, it is late. I'm having a tough time. And then what's this last one?
10.
I hope we go home early. So you guys, what's this last one?
Chapter 10, which is
Chapter 10. Why is it chapter 10?
because it's a correlation between X and
I
Y.
have age and net worth. Are those two different categories of the same thing?
No. They're two different
They're two
variables.
different things, two different variables, and a list of each of those things. Even if they were categories, I'd only have one of each. Right? If they were categories, I'd only have one of each, unless I had stuff along it. There's no stuff along the sides. Do you guys understand what I'm saying?
Mm-hmm.
So it can't be a chi-squared matrix because there's stuff along the side. It can't be a chi-squared list because chi-squared list would only have one under each one. So and it can't be ANOVA because there's only two of them. Like they were saying earlier, last class. Perfect. Right, Dennis? That's what you said last class. Okay, so this one is
Chapter 10.
chapter 10. Thank you.
Correlation.
Okay, so what I'd like you guys to do is tell me what kind of problem is this? Can I make it bigger? Let's do that. What kind of problem is it?
Chapter 10.
Okay, so take 5 seconds on your own to figure out what kind of problem it is.
Yes.
Final exam is in 1 week. Talk to your neighbors about it.
Okay, so basically, I think it's
It's a chapter.
No, it's chapter.
oh yeah,
X and
Okay, guys, what is it?
winning bid.
Chapter 10. Why?
Problem says a correlation.
There are two lists. These are two different things. These are two lists. Sarah, on board?
Yes, there's two
It
lists.
can't be a chi-squared matrix because there's nothing up here.
Yep.
It can't be a ANOVA because there's only two lists.
Yep.
It can't be chi-squared list because this is not observed and expected.
Yep.
Do you guys understand?
Yes.
So this is, and also it says linear correlation. Is that what you're going to say?
Yeah.
Yeah, it says linear correlation. So this is list. This is my x's and my y's. Good.
So
Yes.
no other problem will say linear correlation.
No other problem will say linear correlation. It might say
Correlation.
Right. No other problem will say linear correlation. Yeah. But chapter 10 will sometimes say relationship, which could be 11.2 also, but it won't have it won't have categories up top.
Yeah.
Yeah. Okay, 5 seconds on your own. And talk to your neighbors.
It's a matrix.
It's the animation one. That's the
It's a matrix. It's a matrix. Yep. Well, it's a matrix.
I did a really good one on accident.
Really?
In my car.
Yes.
Oh, yes. This is a yes or no.
Okay, what do you guys think it is?
Matrix.
11.2.
Chi-square
Chi-square
matrix.
List?
11.2. Why?
Because there's things on the top.
Categories, yeah, and these ones. Makes sense? Categories across the top and the side, and this is not observed and expected.
Yes.
Also, see how it says independent? Test of independence is a
Matrix.
chi-square matrix. Remember, it'll either be no relationship, independent, no preference, or no difference.
Difference. Yep.
Yeah. How about this one?
Well, maybe make it smaller.
Well, yeah, because it's hard to read.
Okay.
So this. The numbers on the side are kind of important.
That's chapter.
Sort of 0 through 9. What that is.
That's chapter. I feel like it's chapter 10.
Okay, what do you guys think it is?
Chi-squared list.
Chi-squared list. These are my observed. Everybody okay with that part?
Makes sense.
Another thing is, see what it says frequencies?
Uh-huh.
I won't always say frequencies. Like the last one didn't say frequencies, even though it's chi-squared. But this one, frequencies is a dead giveaway that you're looking at a chi-squared.
Okay.
All right, so then you'd have your. We'll go through a different one, maybe smaller one. Okay, everybody, 5 seconds on your own. Talk to your neighbors.
Because there's 3 of them.
Okay, let's go through it. Can it be chapter 10?
No.
No, because there's more than 2, right? Can it be chapter 11.1?
No.
No, because again, there's more than 2. There's not observed and expected.
Yes.
Can it be a chi-squared matrix?
No.
No, why?
There's nothing on top.
Yeah, there's no labels up top. Do you guys see that?
Yes.
There's no categories up top. So, can it be a ANOVA?
Yes.
Yes, because there's 3 or more lists. ANOVA.
It says me.
Oh, and it says me. Totally. Good? Okay, next. 5 seconds on your own. Oh, maybe 10 seconds. This is a tricky one. 10 seconds on your own.
Uh-huh. Okay.
Talk to your neighbors about it.
No.
This is.
These 2 are observed and the bottom one is expected.
How to explain it. It's the one where we have to do the little.
April, do you want to read this one for me? Read it for us.
I can't, it's cut off.
Oh,
Can you read the center?
here. I'll give you 2 smaller.
Table includes expected something.
Read it now.
The table below lists the number of games played in the Baseball World Series
Quiet. Not you.
as of this writing. That table also includes the expected proportions for the numbers of games in a World Series, assuming that in each series, both teams have about the same chance of winning. Use a .05 significance level to test the claim that the actual numbers of games fit the distribution indicated by the expected proportions.
Right, so what are we talking about?
Goodness of fear.
Well, what are we talking about? Are we talking about cats and dogs?
No.
No.
What was it? World Series games.
Yes.
So, what's up with the... So is it 3 lists? Is it 3
No.
lists? These are my 3 categories and these are 3 lists?
No.
No. Is it... Can't be chapter 10.
No.
Well, it could be chapter 10. Could be chapter 10?
No. Chapter 10 should only have 2 X and Y's.
Okay, so then... So then it's gotta be one of those chi-squared things. Which one is it?
List.
Alright, so these are our categories. So then are these our categories also?
No.
So a matrix? Why are these not categories also?
Well, it says expected, so.
It says expected. One says expected, what's the other one say?
Actual.
Actual
Actual.
is another word for
Observed.
observed. So these are our observed and these are our expected proportions, but really our expected is going to be down here. So
Yep.
it says 2/16 of what? Of the total. We have 103 total, so this would be 2/16 of 103. You guys kind of follow me?
Yes.
This would be 4/16 of 103. So then my actual number would be like, I don't know. 2 divided by 16 times 103. 12.88. Right? And then this one would be 25.75. Good so far? You guys sort of good with this? Yes. 32.19. 32.19. Okay. All cool?
Yes.
Okay. 5 seconds on your own.
Beautiful.
This is very straightforward. Talk to your neighbors. Oh, yeah, talk to your neighbors.
Matrix.
Correct.
All right, what do you guys get?
Chi-squared.
Yeah, chi-squared matrix. You can totally see it there, right? Perfect. Also, they're talking about a relationship. Another thing I want to point out this last one is, see how it says proportions? Proportions and frequency.